Welcome to today's session. In today's sessions, we will discuss about radio receivers and measurements of radio receivers. Actually, we will be studying about super heterodyne radio receiver in communication systems. To receive our information, we need our receivers. Here we will be discussing about super heterodyne radio receiver. Before going to super heterodyne radio receiver, first we should know the important characteristics of a receiver. The important characteristics are sensitivity, selectivity, and fidelity. Now we will see clearly one by one what is meant by sensitivity. It is defined as the ability of receiver to amplify weak signals. Actually, while transmitting our information while receiving, as it is a long distance, the after transmitting that much distance, the receiver signal may be weak. As the receiver signal is weak also, if the receiver has good sensitivity, then it can able to identify that weak signals and it should amplify that weak signal. So it should have that much ability to receive the weak signals also. If we define this in terms of voltage, which must be applied at the receiver input terminals to provide a standard output power at the receiver out. Coming to the sensitivity actually expressed in millivolts, this is the graph of sensitivity. For practical receivers, sensitivity is expressed in terms of signal power, which is required to produce minimum acceptable output with minimum acceptable noise. Sensitivity of super heterodyne receiver mostly depends upon the gain of RF amplifier and gain of IF amplifier. RF means radio frequency, IF means intermediate frequency. So, for receivers, the sensitivity should be high. Coming to the next parameter, selectivity. Selectivity is defined as the ability of receiver where it should able to reject the unwanted signals. While receiving our information, there will be so much of information, but which we require, which is the acceptable in output input signal, only it should accept that particular signals. Any other unwanted signals, it should have that ability to reject the unwanted signals. That is known as selectivity. It depends on receiving frequency and moreover response of IF section. Coming to the other characteristic, that is fidelity, it is the ability of a receiver to reproduce all the modulating frequencies equally. Here in the figure we can observe here. So it is also one of the important characteristic of receivers fidelity. So for the receivers, the sensitivity, selectivity and fidelity, all these three characteristics should be high. These are some of the receiver characteristics. Coming to other topic of today, that is information and channel capacity. Actually, what is meant by information? Information is defined as a sequence of letters or symbols which will carry a message signal with a meaning, with a specific meaning. Coming to sources of informations, we have two types: analog information sources and digital information sources. Analog information sources contains all continuous signals. Discrete information sources consists of discrete letters or symbols. Information content of a message means how can we identify the information content in a particular message, means it is represented by the probability or uncertainty of the event associated with the message. We can define this information content as the probability of occurrence of a message is inversely proportional to the amount of information. So if you see the relation between information content of a message, ik equals to log of 1 by pk, where probability pk is probability of occurrence. Then the unit of information is bits actually. So this is the information content representation in equation where ik equals to log of 1 by pk. Coming to entropy, entropy is the average information content. Is defined as the average amount of information conveyed by a message. It is denoted by h of h. So the equation representation h of x equals to summation k equals to 1 to mpk log of 1 by k. Coming to the properties of entropy, entropy is always non-negative where h of x greater than or equals to 0. Entropy is 0 when probability of all symbols is 0 except probability one symbol is 1. Entropy is maximum when probability of occurrence of all symbols is equal. It is log 2m. We have different types of entropies like joint entropy, conditional entropy, and mutual information we need to know. Today we will end up this session. In the next sessions, we will understand clearly about our mutual information and discrete channels and some of the algorithms. Thank you. Thank you for listening.